All right, today's topic is related rates. And here we go. A coffee pot has the shape of a cylinder with radius 5 inches as shown in the figure. Let h be the depth of the coffee in the pot measured in inches, where h is a function of time, measured in seconds. The volume V of coffee in the pot is changing at a rate of negative 5 pi squared of h. So now we can say that the dV dt is negative 5 pi times squared of h. Now the negative means that the amount in the coffee is decreasing. The volume of V of a cylinder in radius with radius r and height h is V equals pi r squared h. A, show that dH dt is equal to negative square root of h over 5. Well, here is the volume, and we can plug 5 in right away because the radius is not going to change. As the volume goes down, the radius stays the same, as opposed to like a cone, where as the volume drops, the radius of the cone is going to change. So we wouldn't be able to plug values in right away for a cone, but for a cylinder we can. Let's take the derivative of this. The dV dt is 25 pi. Derivative of h is just going to be dH dt in this case. Now they tell us what dV dt is, and so we'll plug that in. And then we just divide by 25 pi, and we got the negative square root of h over 5. B, given that h is 17 at time t equals 0, solve the differential equation. So solve this differential equation. We split the differentials here. And so we divide by square root of h, multiply by dt. Take the integral. The integral of negative 1/5 is negative 1/5 t plus c. And then this is h to the negative 1/2. So when we add 1, we get h to the 1/2, but then times 2. So there's 2 square root of h. We need to use the initial condition of 17, 0, or 0, 17. And that's right here. So C is 2 square root of 17. So we go back to this spot right here, and that's right there. And we know we have 2 square root of h, and there's the constant right there. Well, now we're going to multiply by a half. That's negative 1/10. And then, multiply by a half. 2 times a half is 1. So we get 1 there. And then square both sides. So there's the function. At what time t is the coffee pot empty? Well, we know the coffee pot is empty when the height is 0. So we put 0 in for h. Square root both sides, or really we just need this to be 0. Minus square root of 17. Multiply by negative 10, and it's 10 square root of 17 seconds. Here is the rubric. Notice that again, for solving a differential equation is worth 5 big points. So if that's on there, that's going to be 5 big ones for you. Ship A is traveling due west toward Lighthouse Rock at a speed of 15 kilometers per hour. So we know that this ship A is going towards the lighthouse. That means that the speed, or the dx dt, is negative 15 because this side is reducing in size. Ship B is traveling due north away from Lighthouse Rock at a speed of 10 kilometers per hour. So we know that dy dt is a positive 10 because this side is getting longer. All right, let x be the distance between ship A and Lighthouse Rock at time t, and let y be the distance between ship B and Lighthouse Rock at time t, as shown in the figure above or off to the right here. Letter A, find the distance in kilometers between ship A and ship B when x is 4 and y is 3. Well, this is hardly calculus. This is just Pythagorean theorem, so 5 kilometers. B, find the rate of change in kilometers per hour, the distance between the two ships when x is 4 and y is 3. So we have x squared plus y squared is, let's say, distance squared. Well, we know that x is 4, y is 3, d is 5. We know dx dt, and we know dy dt. So let's take the derivative with respect to t. We get the following. You can read this. Since they all have a 2, we can ignore the fact that there's a 2 there, or divide each side by 2, I suppose. X is 4, dx dt is negative 15, y is 3, dy dt is 10, and d is 5, or distance. So this ends up being negative 60 plus 30 divided by 5. Negative 6 kilometers per hour is what dt is. Letter C, let theta be the angle shown in the figure. Find the rate of change of theta in radians per hour when x is 4 and y is 3. Well, we know that this is a 3, 4, 5 right triangle. 3, 4, 5 right triangle. And then this side is changing and this side is changing and the angle is going to change. So we can't plug in any values right away. But what we do know is that the tangent of theta is opposite over adjacent, y over x. We'll take the derivative of both sides. So the derivative of tangent is secant squared. And then we have bottom times derivative of the top minus top times derivative of the bottom over bottom squared. We know that the secant secant of this is reciprocal of cosine. Excuse me. So we have 5/4. So 5/4 is secant. We need to square that. Of course, that's going to be 25/16. And then we fill in the values. X is 4, dy dt is 10, and so on. Y is 3, dx dt is negative 15, and x is 4. So we get 40 plus 45, that's working the top out, over 16, that's 85 over 16, but then we're going to multiply, and I have that down here actually, then we're going to multiply by 16 over 25. So 17/5 radians per hour. So here is the rubric for all of that. The best fencing plan. A rectangular plot of farmland will be bounded on one side by a river, on the other three sides by a single strand electric fence. With 800 meters of wire at your disposal, what is the largest area you can enclose and what are its dimensions? Well, this is, is there a, by a river? Yeah, that's the river right there. So we have a width, a length, and a width. We don't need another length because we have the river there. So the area is length times width, and the perimeter of just the fencing, the length of the fencing is 2W plus L, 2 widths, 1 L equals 800. Well, we're going to subtract 2W over there, and we're going to replace this L with 800 minus 2W. So, yeah, so we have W times 800 minus 2W, distribute. And now here's where we take the derivative. So here's the derivative and setting it equal to 0. We can factor out, well, it just ends up being the width is 200 from here. And then if you plug in, let's see, if you plug 200 into here, we get 400. Subtract the 400, length is 400. So what is the largest area you can enclose and what are its dimensions? So there's the dimensions and it's 8, how many, 1, 2, 3, 4, 80,000 meters. Meters squared would be the area. Assume that f has derivatives of all orders for all real numbers. F of 0 is 2, first derivative is negative 1, second derivative is 6, and the third derivative is 12. Which of the following is the third order Taylor polynomial for f at x equals 0? This, I suppose this was a multiple choice, but I don't have the choices. Yeah, we just wrote what it was. 2 and then minus x plus 6 x squared over 2 factorial plus 12 x to the third over 3 factorial. And we don't need any minuses because it's centered at 0. This is actually a Maclaurin. Which of the following is the sum of the series? Well, if you look at this, it's not very obvious in this form that this is actually geometric. But if you start plugging in some values, you get 1 pi over e squared, pi squared over e to the 4th, pi to the 3rd over e to the 6th. So on top we're multiplying by pi, and on the bottom we're multiplying by e squared. So r is equal to pi over e squared. And the first term is 1. So here's a sub 1 over 1 minus r. We can multiply everything by e squared. So multiply everything by e squared, and that gets rid of that complex fraction. So you get e squared minus pi. Find the area. That's just going to be top minus bottom. So y squared. Oh, no. These are x equals, my mistake. So we're actually doing right minus left because we're doing this with respect to y. So we're integrating from actually 0 to 1 here and taking y squared minus y to the third. And yeah, so this is the antiderivative. Plug 1 in and you end up with 1/12. Finding a second derivative implicitly. So we need the first derivative. And we get 6x squared minus 6y, and then times dy dx, or I guess when I did this I wrote y prime. So y prime is x squared over y, because we're going to subtract. So we have subtract the 6x squared and divide by the negative 6y. So that's where you get x squared over y. The second derivative is bottom times derivative of the top minus top times derivative of the bottom, which would be 1, but then times dy dx again. And we're going to replace that with x squared over y. Notice that's right here. Replace that with x squared over y, and then over y squared. Now that's equal to, So we just kind of simplify, combine all the terms we can. Now we need to multiply everything by y to get rid of this piece right here, that right there. Multiply by y, 2xy squared minus x to the fourth over y to the third. This one, the technique that we need to use to do the integration is common denominator. So I can make this x to the sixth over x to the third plus 5 over x to the third. Well, that's just x to the third right there when it cancels out, and we have plus 5x to the negative 3. So the antiderivative is going to be, this is x to the third. So 1/4 x to the fourth. Yeah, I think I messed that up when I did it. Let me check. Yeah. Okay, there we go. The derivative of this is 1 over 3x times 3. So that's just 1 over x. This one, the limit as x approaches 0 of this. Now, that's 0 over 0 when you plug 0 in, so why not use L'Hopital's? Well, the derivative of this is 0, derivative of this is 1. Those are kind of gone. So we need the derivative of 1 plus x to the 1/2. That's 1/2, 1 plus x to the negative 1/2. So that's 1 over 2 square root of 1 plus x. Now, the derivative of the inside is 1. So we do multiply by the derivative of the inside. Now, when we plug 0 into this, we just get 1/2. How about some way back to August? Limit as s approaches negative 2 from the left. Negative 2 from the left. Well, that's going to be up here at 3. Limit as s approaches negative 2 from the right. Yeah, 3 up there. Limit as s approaches negative 2, 3. Now, you're probably looking at that going, well, there's a cusp there, but that means it's not differentiable. It has value, but it doesn't have a derivative. And then p of negative 2. Well, p of negative 2 is 3. Now, it'd probably be much more interesting to look at 0. The limit from the left is 0. The limit from the right is negative infinity, or if it was a multiple choice, maybe they have undefined. And then the limit at 0 does not exist. Let f be the function defined as f of x is 3 minus x, and then ax squared plus bx, and that's for x is less than 1 or x greater than or equal to 1, where a and b are constants. If the function is continuous for all x, what is the relationship between a and b? If it's continuous, so when you plug 1 into here on the top, you get 2. Now, if it's continuous, the two y values will meet each other. So this is equal to a plus b. So that's the relationship right there. Find the unique values for a and b that will make f both continuous and differentiable. Well, the derivative of the top is negative 1. So negative 1 has to equal, and then if we take the derivative of this at 1, what do we get? We get 2a plus b. So now we have a system of equations. Here's the 2a plus b is negative 1. If we subtract, we get a is negative 3. So we plug negative 3 in for a here. How do we get 2? We got to add 5. So negative 3 and 5.